By that time, I think things will be standardized. Everybody will be working on small things like.
Okay. So the first thing that will come into place is, I think, net endpoint security and then network security, in the sense that you won't be able to insert or take out USB drives from your laptops. And the second thing is, you'll be able to operate your laptop only when you connect to company network. So only when you're connected through VPN into the company network. But anyway, so these are all standard of corporate policies which big companies have, including parent company. But when they get implemented here, hopefully not this year, hopefully not middle of next year also. Let's see.
Okay.
And usually the standard softwares which implement these kind of rules are developed mostly by Microsoft. And due to compatibility reasons, the final nail on the coffin might be we all have to shift to Windows.
We all have to shift to
Windows.
Oh, okay. That would be a huge step.
Yeah. Yeah. Let's see.
Then okay. Then using cluster is also going to be tedious.
Yeah. The day they put Windows on a cluster, that day I think there should be a revolt in front of every Reliance.
What do these Geo people use? They also have.
Well, they use containers. So for enterprise clusters or data center, like so, for example, the hall in Jamnagar where our cluster is housed, that same hall, we take only 2 racks, 2 rows, not racks. Racks is what, 20 or something. 2 rows. The other 40 rows, sorry, not 40, the total of 40 rows in the hall. Other 15 rows or 20 rows are taken up by Microsoft Azure. So Microsoft Azure has their data centers in Jamnagar and in Nagpur.
Okay.
So they also, like when we set up the cluster, we went with AMD, right? AMD ROM. That time Intel was also pushing Cascade Lake AP. But we did not go with Cascade Lake AP because for the same performance, like very similar performance specs, the Cascade Lake AP cluster would consume double the power. So your electricity bill will go down.
Okay.
But Microsoft apparently doesn't have any problem paying electricity bills. So they made the cluster out of full Cascade Lake APs. And it heats up like crazy. So on the software side, also they're not so considered. They don't have high performance needs, right? Like it's like database kind of applications where database kind of applications, enterprise applications where you'll have a database of Excel sheet equivalents running on the server in a container, Docker or some Kubernetes or orchestration, Docker or some Microsoft's own VM containers. And there'll be applications which are writing files one thread at a time, something like that. So usually, how they optimize, like in our case, we keep running our jobs. Okay, sorry, the program has started, not program, sorry. The discussion has started. Okay, people, hi people. We'll finish up this chat in 1 minute and then we'll start up with the actual thing. So yeah, so Microsoft or the other kind of enterprise applications which go on in this enterprise grade servers or clusters, they use 1 or 2 threads only per node, and the data writing is mostly IO, and data writing is mostly like once every 2 seconds, 3 seconds, like this, and burst writing. So these people try to optimize on power savings. Like depending on your usage, they develop these power controllers on the power supply unit such that if they see that on an average the read, write, and IO speed and all those, or CPU consumption is less than 30%, they will actually power down the power supply unit directly. And that's how they save power. For us, we can't do that. For us, it's going full throttle, the entire power supply, like for days at a stretch, right? Like because we're using most of the cores and most of the channels at least, and so on. Yeah. So the optimizations that go on for enterprise applications are very different than what we do in HPC.
Okay.
Yeah.
So what I was saying, like hard coding, like the way we are like writing C++, this thing, that thing. So we are using Linux, like continuous compiling, running, and all. So they don't do that kind of stuff as of
They use Windows Server 2008. Last I saw, I think they have upgraded to 2012.
Okay.
Okay. So no, it's a very different ecosystem. That's why when they first came across our HPC applications, they were very surprised that why do we not use containers?
Okay.
And then Santosh had to explain to them that the moment you put containers, half your bandwidth memory storage limitation, like half your memory storage will be taken out by the containers themselves, by some redundancy default rule that they have and so on. Anyway, so that's a different story altogether.
Okay.
So, okay, I see almost everyone has joined. Okay, although the mics are all off, this is mostly going to be a interactive session. It's called camp, but I don't know who named it that. It's not a camp like a boot camp kind of thing. It's more of a, that's what we were talking to the Rachel about, that the need for this session or sessions, series of sessions, is because there are certain policies and procedures which we need to follow, some of which will actually make our lives much easier once we start developing going into big libraries and coding our own libraries and so on. And till now, different groups have been following their different styles of managing software and etc. This is a common forum where we can come together and discuss ideas of what to standardize, what the good practices, what you think are bad practices and should not be put into the text, like rule book and so on. So please feel free to unmute your mic anytime, shout and grill me any like on any topic you want. The topics we are going to discuss today, I have very little idea about those anyway. So mostly I'll be Googling along with you, and we'll see how it goes from there. Okay, so I'll share my screen just to begin with. Oh, disclaimer, all data that you see on the screen is confidential and proprietary to Sankhya Labs Limited, copyright 2021. So please don't share unauthorized screenshots of these outside. Okay. Okay, I think we have enough people right now to start off with. Okay, I'm going to just assume that you can see my screen. And here is the schedule for today. So as you can see, today's discussion is mostly on non-coding stuff. This is more like the processes that we follow to ensure the decoration on top of the code, the processes and policies that we follow to make life easier, in the sense that many of you might already know all these things and are already following this. If you already know it and you're not going to gain much out of the discussion, please feel free to like drop off or like join the next session and so on. Okay, so the plan is that, okay, just as a context of why these processes are needed at all. When we were, or many of you might have been coming from an academic background, like research, or from other industries. And in the starting days of your coding career, you might have seen people, or we might have done it ourselves also, that we write our simple code and then zip it up in a zip file or tar file and then mail it to a collaborator, right? And they edit it, and the back and forth goes on. In the beginnings of Sankhya also, this used to go on because we used to come from a very big industry culture. So then over time, what we realized is once clients start coming in and there are specific demands or requirements from the code and specific functionality that has to be maintained with every release to the client, we realized that it is becoming a hell to keep track of the versions and which folder has which file and so on, and which code is buggy, which code was the correct one. You have to do a Google search on your mail tab, and that doesn't help at all. Okay, so like this, the mail exchange of zip files and tarballs became ridiculous after some time. So usually the industry practices, and the second thing is, suppose you are writing your code and you want to make a small modification and experiment with something. Usually what we do is make a copy of the same file and then change the file, rename it with some test_2 or test_backup dot some BKP or something like that. And we'll keep modifying that. Then we'll find another idea which we can try out, and then it becomes test_backup.2 and so on. So this redundancy or duplication hell that goes on, that will introduce bugs invariably later on, like as the code becomes bigger. So what this nice people who developed Linux, I think. I keep confusing who developed Git. Was it Richie or Torvalds? Anyway, one of those two.
Torvalds.
Torvalds.
Yeah,
Okay.
that.
Yeah. So both of them developed a lot of nice things. So it's confusing who did what. Yeah. Tech was Richie, right? Oh, okay, fine. Yeah. Okay, Torvalds was Git. So Git basically is this mechanism to version your software, much like what you see on Google Drive nowadays. So if you upload a file to Google Drive and if you right click the file and you get this manage versions, then you can go back and forth between versions you would have overwritten the file with and so on. So this was there for some time early on in the coding communities, where you don't have to do that duplication hell. If you keep changing your code, committing your code using Git, then you'll be able to go back and forth between versions, whereas the file that you're seeing on your desktop remains the same. But you can also branch out and create multiple versions of the file and in a very controlled manner. And then you can merge back multiple changes from multiple versions of the file together into a single file again and so on. So that is what we'll go through to see how a big library evolves over time, starting from a single main.cpp into headers, source files, libraries, and so on. And then Git itself is a version control software which doesn't need any browser interface and all those things. It can reside as a standalone application on your desktop. The only thing is now, since you want a repository to where you want to safely store all these codes, your source codes, these services have come up like GitHub, Bitbucket, GitLab, and so on, which basically provide a nice GUI front end to Git. And they also have this added benefits of creating issues, milestones, like all the management stuff, like timelines, deadlines, due dates, and priorities, and all those things. Okay, so since all of you will someday be setting your own milestones, your own projects and labels and due dates and so on, we'll go through that also a bit. And when you're collaborating with multiple people on the same piece of code, then there'll invariably be fights over my code is better than your code. And when you try to merge two conflicting codes together, then someone has to make a decision on which part of which code is better and which has merit and demerits and so on. This discussion is basically called code review. And this can be formalized and made more civilized by putting it in a comment interactive form, instead of just having a shouting match over a Zoom call or something. So we'll go through a bit of mock code review also, just to see how to review other people's codes and give constructive criticism or critique other people's codes instead of criticize. Okay, so that's the first half. And no, that's actually the first half of the first half. Oh God. Okay. Then there is unit tests. Unit tests, as you know, everyone hates to write them, but they have to be written, because once you have started building a library and those features which were very obvious to you now, 6 months later, you won't even remember them. And then if you need to change something, make a fundamental change in the software, and you go tweak the first file you had started off with without much recollection of how it exactly works, invariably you'll break something. Just to keep a guard who says that no, you have changed something which functionally breaks the code or a feature, you create your own unit tests, which are like consistency checks or assertions, which keep running every time you make a modification in the code, saying that, okay, this change you have made in the code, that doesn't break any functionality as far as you have told me what the code is supposed to do. Okay, it might have broken something very sublime and very implicit somewhere, but if you don't write a unit test for that feature, it will go undetected and it will create a headache with your clients, and angry customer emails will come and all those kind of things. Okay, and then usually, again, like the zip compressing into zip or tarballs our codes and sending it over by mail, the usual way we used to compile and run codes is just take the compiler, put maybe a -03 and just compile the code and then run it, // right? Or MPI run this thing, that thing. When you have a library with suppose 100, 200 or 1,000 different files, it becomes a bit ridiculous to just keep writing a compile shell script with a compiler. G++ or GCC, whatever, or ICC. Multiple calls to ICC like this. So instead, we'll programmatically try to build packages. There are multiple ways of doing it. Though if you like shell scripting or bash scripting, you will like this thing called makefiles or make. If you like Python instead of shell scripting, Python scripting instead of shell scripting, you'll like this more object-oriented build tool called CMake, which essentially generates makefiles, and then you compile using the makefiles. Okay, so this is going to be only for C++. It can work for Java, which is also a compiled code, but it's not necessary for Python or JavaScript. So we'll focus on C++ as of now, because I don't think anyone in the company needs Java right now. JavaScript, Python, yes, it's needed. Those don't need compiling because they're interpreted languages. So that is unit tests and build. And then finally, we'll go through CI/CD, which is essentially the build. So it's basically an automated pipeline where the GitLab server will do all the tasks that a development engineer would have done manually. Like it will automatically run your test scripts. It will automatically build the debug versions, the library versions, the libraries, the optimized versions, and then package them nicely into zip or tar.gz or something, and then put them into some website where you can download the final product from. So on. So this is the first half. Then we have break. Then we'll discuss after the break what we will do after the break. Okay. So regarding Git workflow, so we'll start. Any questions or any particular thing that you would really like to see covered in this half? Like you can just freely speak about any topics you would want to see covered in for these related to these particular topics that are going to be covered in the first half. Okay. As I said again, this is not going to be a lecture. It becomes very monotonic, and I get very bored very easily. So we will try to keep it interactive, and please feel free to unmute your mics and ask any questions. Okay. So for Git, just as a curious survey, how many of you have used something called Git reset? You can unmute and say yes, or in the comments, maybe you can say, I'll keep the comments on. Where are the comments? Okay. Okay, Git reset? No? No one? Okay. Rebase? Okay. Git commit. Oh, Nitin, you have used reset. Interesting. Was this because there was some change you made which you wanted to discard later on?
Yeah, actually, yes.
So tell me something. So if that was the use case, or that was the situation you were in, wouldn't it be much easier to just copy paste the changed code somewhere outside the folder and just delete the Git repo and clone it again?
No, it's true, but well, basically when you Git reset, no, it'll be recorded like that you made a mistake and you reset it.
Oh, you want to record? Okay, that is very nice. That is very brave of you. Usually I just delete the repo and start over again.
I used to do that too, but then I used to repeat those mistakes too.
Okay, fine, sure. So, okay, fine, nice. So we will hopefully not, okay, we will end up using Git reset every now and then. So we'll cover that also then. Any other commands per se? Okay, let's start off with the coding. Then we will see what we come across, because we are going to do some live coding. This is only going to be live coding. I don't have any slides or anything. Okay. And when you do live coding like this for hours at a stretch, definitely there will be at least 20, 30 bugs which will come across. So you'll have a nice grilling session here. Okay. So what we'll do is, if you go to any of the libraries that you have access to inside the Sankhya Sutra groups or your respective groups. So I have access to this one. So if you look at a typical library, okay, this is not a typical library, this is like a big fat library. The first things that you'll see is, apart from the examples and libs and tests, there are a lot of these garbage metadata looking files. So again, most of you might be knowing a lot of about these metadata files, but we'll go through them also. Instead of just, so what I used to feel like when I used to see libraries like this for the first time is that I used to get really scared. Like, what is going on? I have no idea. Like, I understand inside libs, I can see an include that I understand, and I see a src that I understand. Remaining other files, I have no idea about. So let's start from a simple case like that. Huh? Like, you have a very simple. So what I'll do is I'll create a test group where we can do a lot of these experimentation. So development operations. So we'll do something here. Huh? I've created this group. I think it is public. No, it's not public. I'll make it public so that you can keep cloning this repo and playing around with it. Okay. So yeah, you can now access the repo. I think since it is public, you can also comment here as you wish. And we'll use this repo as our starting point of a simple code. So since we are in a company which does scientific and engineering simulations, we'll start with a basic use case where we have a 2D simulation, a very simple simulation. So standard simplest simulation, which is of some use to someone, is I think the finite different heat equation, which is simply a 2D grid with a Laplacian being added repeatedly to the temperature field. So we will try to create a small code and try to see what the Git functionalities are. So everyone is familiar with just creating a code in Git, creating a repo in GitLab, right? Like that. Otherwise, I can start off with that also. So let's see. Sorry. Maybe we'll start off with that. So create a blank project, or you can just go to your own. So usually what happens is in GitLab, you have an SS Labs namespace, which contains all the company official projects, but you also have some space to experiment with your own stuff. So here you have your own things, like you can play around, create your own personal projects and so on. So what I'll do is I'll create, for now I'll create it in the training group itself, but you can create similar repos and play around with them in your personal namespace also. So you can go to new project, or you can click here and go to new project, or you can go here, go to projects and do create new project. There are multiple options Git has given you to create a new project. So here I'll just call it as new project. So this one will be thermal solver. So usually you initialize with a README, because if you don't, in many cases, GitLab doesn't even create the main branch or the master branch. By the way, as you have noticed, GitLab has changed its naming convention to name because master has connotations of slavery. So the main branch.
So maybe, sorry,
yeah.
Sorry to interrupt you. Can you record this session, man? Just in case we.
I think Ravi is recording.
Ravi is recording.
Oh, okay.
Oh, cool. Thanks.
Yeah. Sure. So, by the way, if anyone feels this is going a bit slow, you can keep discussing in the chat if it is too slow. And if you come to a common vote, then we'll go fast. Okay. I'm just like going this way slowly I understood, at the rate, very slow rate with how I understand things. Okay. So you can clone the repo by using this URL. By the way, so before you can clone the repos, you need to just ensure that in your preferences in your profile, you have set your SSH key. So like, for example, I have set my SSH key for different machines. So for your local machine, you'll have your SSH key somewhere listed in SSH. Okay, so this one would be a RSA encrypted key. There's a public key and a private key. Usually you have to take only the .public key and upload it here. The contents of it, you upload it here and give it a name saying you're my laptop or something. and you can select expiry date and add the key. Once you have done this, by the way, if you don't see this folder .ssh is a hidden folder in Linux. If you don't see this folder, it most probably means you have never logged in SSH to another machine, or you haven't generated a key of your own. You can generate a key by yourself by just clicking on this link, generate one, and following this comment, RSA. When you are generating key for this kind of GitLab applications, or any application in general, unless you work in InfoSec, it's better not to create any passphrases, okay? Because then then basically a lot of the automated operations that GitLab is very useful for, those get nullified every time you have to enter a password. Then, okay. So what it says here, specify a passphrase. You can just press enter and skip it. No passphrase. Don't worry, no one's going to steal your data. People have much more important data to steal than our codes. Okay. Again, sorry, this is being recorded right now. Safety is first as a company policy. Okay, so we will go back to our project. And since I've already added my laptop key there, I can just clone with this URL, and I'll go back to my desk. Sister. Okay. Now I have my local copy. Usually the first thing you do after cloning is find out what is the branch you are on. As we said, like there's only one branch right now, the main branch. So usually we'll start coding right away. So we will just do, suppose, a main.cpp and simple hello world. I'll just create some dummy code right now just to finish off a few things. Usage of stdndl is discouraged usually, and /n is the way to go, but we'll come to that later. And if you have GCC or G++ or any other compiler installed on your system, you can just run it to check. So the first thing that you would do is you will add the contents. So if you usually press get status, it will show you what is the status of the code or the changes that you've made to the repository since your last committed change. So as you can see, I have two new files, main.cpp and a.out. So I need to commit those and push them back to the server. So that way it's stored permanently in the history of Git. Okay. And you can revert back to it whenever you want later on, if you want to undo changes and so on. Now there is a small good etiquette about using GitLab or Git in general. Git usually uses a diff mechanism to store only incremental changes over plain text files. If you give it compiled binaries or binaries in general, like a.out is a binary. So for example, if you open a.out, you'll see garbage like this. It's actually not garbage. It has some comments. It's actually hexadecimal encoded. So binaries like this, yeah, this one. Yeah, sure. Yeah. So binaries, for example, cannot be diffed so easily, or actually can't be diffed depending on how jumbled up the binary is by GitLab. So therefore, you'll need, it's best not to commit binaries into Git. So where you can, the way you can deal with this is every time you generate a binary like this a.out, you need to remember that always do rm a.out and so on. Or if you once forget and once you commit it, it will stay in Git's history and it will bloat up your entire repo. So the best way to not keep bothering about this is to create a file called .gitignore. This will list out all the files that you want to ignore and not commit, even if they're present in the repo. I'll mention a.out. And now I'll just look at Git status. So it says gitignore and main.cpp. So I'll comment. So now the first step that you do is you usually add your changes first. It's called staging. There are many reasons why it's a step-by-step process like this. We'll get into the details later. So once you add it, then you commit the code, your repo. So this is like added hello world or add hello world. And then if you want, so till now, till this step, the files are committed only on your local laptop. If you now really want to synchronize it with the online Git hosting server here, or this repo, online repo, remote repo here, then you just do a git push. Okay. Or if you want the bigger version of it, you can do git push remote something, remote origin master or main something. But git push is enough for now. So these are the 3 steps. You add, whenever you make a change, you add, you commit, and you git push. You can do multiple commits before you do git push. That is up to you, what frequency you choose. Usually it's a good idea to git push every 1 hour, so that if you happen to be in a natural disaster or something happens, the company will not lose out of at least maximum 1 hour's worth of coding. Okay, so git push every hour on the hour, git commit as soon as you make small incremental changes, like conceptually small incremental changes. Okay, usually, again, this will come in the code review part, but usually what you might have seen is you get so taken away or like pulled into this coding business that you forget to git commit, and in the end, when you compare with the previous commit and the code you have now, there will be like some 5,000 line of changes. The problem is Git is useless in that case, because Git's main power is to show you small diffs or additions and subtractions between previous and current files. And if you have 5,000 lines being shown as a single diff, it's okay, it's possible by some huge amount of labor to go through all the diffs. But usually if you keep your Git commits to conceptually small modules, like you change a small thing and commit it, then when you get diff between previous and now, you'll be able to see exactly a small conceptual portion has been added and so on. And later on, we'll see in code review, your reviewers will also find it nice to go through things conceptually by doing a git diff. It makes everyone's job easier. Okay. So now,
I have a small question here. Yeah. So suppose so when we code, sometimes we actually hard code some of the values, sometimes some of the parameters, and we keep on varying those parameters sometimes. So then how can we follow this committing like every time every change? So that is.
Oh, okay. I see. You mean there's an environment file kind of thing where you, okay, understood.
No, if you have a config file, something like where you are fetching the parameters, then it's okay. You just keep on varying the parameters, and that is not committed. But when you hard coded some of the values, inside the code,
understood.
So you keep on varying just to test which parameter actually good.
Yeah. So I understood. So usually, so for example, so this is a case where you're actually committing the results along. You're committing the results along with the input parameters, right, for a particular run. So you are basically building small case studies essentially.
You can say
yeah. Okay. So usually, if you are going to, so do you need to save your parameters for each and every case? Means, do you need to save each and every case study?
No, it is not like that. So suppose I am just building some some algorithm in the beginning stage, where I'm not sure whether this thing can work or this thing cannot work, and I'm just keep on varying some parameters to see whether this method is working or not. So in those cases, how can you proceed with committing? Should I just hold on for a while, and then when I'm sure, okay, this is the set, then we commit, something like that.
Something like this.
So you can consider like a Gaussian fitting also. So you have data and you want to fit it with some values, right? Some Gaussian mean and sigma, and then you keep on varying to see whether it's actually fitting or not. So then, should I commit for every variations of this mu and sigma, or should I, once I finalize, then only should I commit?
Okay, understood. See, the thing is, okay, you're saying there is a scope that you will finalize and not change it ever again, is it?
Yeah.
Oh, okay. Yeah, then you can keep committing, because commits will, like if you're experimenting, that is also part of your workflow, right?
Yes.
I think that what I thought initially the question is that you have your code now. Now there is an input script which keeps changing, like it's like OpenFOAM input scripts. Like OpenFOAM itself, the software won't change, but the input scripts will keep changing, or the input scripts will keep changing depending on the problem you're solving. So I thought initially the question was, do you keep committing all the committing the input script also, and then for every problem you keep changing it in the thing? Okay, no. So if that is not the case, if you are just experimenting and then finally you'll settle on a good value, then you can keep committing it. Means as long as after development time it will converge to a stable code, then that can keep happening in the history of Git. It's fine. Just that the input scripts of an OpenFOAM file does not need to go necessarily into Git. You can use Git as a version control for case studies also, but then it's best to keep it as a separate repo, not with the actual code itself. Yeah. Okay. So fine. These are, I think, two different cases that, yeah, you mentioned development. You thought it was a test case input parameter. Okay.
Somadeep, I have it's just a silly question, man. This, when you say commit, you said that comment, no? Comment. So maybe we have like a big comment. Maybe there's a, can you pass a file or something into this, like which will tell you the description of the...
Oh, a file, I am not sure. Yes, you can change the body of the commit message.
Okay. Okay.
So this is a abstract summary. You can, so just give a summary, like usually this is 100 characters only. If you really want to describe what happened in this comment, then you can, I think I have to check again. This is something I keep forgetting.
There's a comment box for every commit.
What is the syntax for that?
No, you just commit it and then GUI of GitLab you can use.
Oh, okay. Like GUI will make it very helpful.
Oh, okay. You can just give it in. Yeah, okay. Fine. No, okay. You can directly give it there. Okay.
So I think during commit, instead of -m, we can, if you say -a, it will open a file.
Okay. Yeah, -a.
Oh, is it?
Yeah. It will open a file and there you can describe, and it will list by default, it will list all the file names which are there, which are going to be which you have changed actually. So this way, this is commented. So right now, let's say after modified main.cpp, you can uncomment it, and below that perhaps you can write, okay, I have done this thing in this file, and it will list all the files actually, whatever I changed.
Okay, nice. So instead of -m, -a, right? And then
and then after, I think you have to put Control-O to commit, to put this into the message, and then enter, and then after that -x, it will get committed. Yeah, something like that.
Okay.
I'll check it out. No issues. I'll check it out.
Sure. Yeah. So one thing is the GUI that you get in GitLab, this commit message, that is supposed to be the equivalent of -m. So usually commit summaries or -m, these small messages, they come up in your file histories. Like again, if I go to a project which has a lot of commit messages, and if I go to the graph, this is how it will look. Now, as you can see, if the commit message goes very big, it becomes very lengthy. So usually people prefer to restrict the commit messages to 100 characters. And for the actual essay type descriptions, if you want to put such a thing, you can use -a.
Okay.
So the GUI part, I think, is for the smaller messages. It's better not to put the big descriptions here itself. So GitLab, in that sense, I think doesn't give you an option for.
No, not here actually. So when you push into a repo, right, you open the commit and then you can add a description, like a comment, same as for branches.
It's -a.
No, not -a. So you've pushed it, right?
Yeah.
You go to that commit and you can open that commit actually, and then there is a comment section there.
Push it. Okay. If I open that commit, as in how?
In the GUI. So basically in the file history, there's
here.
Right. Those are your comments, right? No, just open it. Yeah. So there.
Okay.
So there is a comment section below, right?
Oh, okay. This is not the commit message per se. This is more of code review. So we'll come to this. So this, okay, by git commit, the essay type comments on git commit, what we mean is that that essay type comment of yours should be available in Git itself. So basically, if you now go to Git, I don't know, since we have not used this. So if you go to git log, just use git commands from GUI, from command line, you will be able to see the big comments also. This is the summary, and this is the big essay type comments. if you added something here, it will stay only in GitLab. So let's do that. Okay. So suppose I say this was supposed to go to Git also, but didn't. I commented. If I now do a git fetch or a git pull, I do git log, as you can see that comment has appeared nowhere here. Okay, so this comment box is actually a GUI feature on GitLab itself. It's basically meant to give comments on, okay, I don't think this hash include string is necessary here. You can just do a normal something something. A code reviewer would say about the diff here. So this is more of a GitLab feature, not a Git commit feature per se. These are actually useful. For example, you can use emojis also here, and so on. So sad. Okay. So for that purpose, for GitLab purposes, it's fine. But if you really want to export it as a Git file.
So sorry to interrupt. Actually, I use -a that is all and message. Git commit a minus a.
Minus a, yeah. So this minus a is actually for add. So as you saw, I did git add dot, which basically adds all the files in dot, like from this folder, all changes basically made in this folder below. Instead, okay, let's do one thing. So just to see what dot out is there, and I hope we still don't have. So let's change the file a bit. So as we said, let's change it to. So git, I can either do git add dot and then do git commit, or I can just do git commit. At one shot, I can do git minus a minus m. Change
Okay.
to. Okay. There's a shorthand for git add dot. And so basically, if someone really wants to utilize the git add dot stage and not go on to the commit stage, there are some use cases where you want to do that. Okay, just stage the files, not committed. So then you can do it separately, or if you're sure whatever you add you want to comment, just use git commit minus.
And add a space dot means like it will add all the files in this folder and the subfolders as well.
Yes. So basically, if I happen to have some folder below, and if I added something here, abc.csv something, then if I do get status in this folder, it will only show that, first of all, I have created a new folder. This folder itself is new. If I now do git add dot, it will show that I have added this file. Now, if I go to some other folder, and okay, suppose I create a cde.csv here, and I go into this folder, and I do git status, it will show it has been added there. So if I do git add dot inside the subfolder, it did not commit the files or add the files in the previous parent folder hierarchies. Okay, so it's dot means this folder and below. I don't care what has changed in the above folders. Okay, so usually it is best to go to the root folder of your repo and do a git add dot. Some people actually prefer to have very fine-grained control over which files they want to add and or not. So then they will, instead of just doing a dot, they will actually give it by the file name. So like this, cd and so on. Then both the files are added like this. Okay. So I'll just remove these unnecessary things.
Samirdeep, is it a good idea to have a document in your local folder, which is basically in which you're writing all the modifications you've done, and then commit that also each time?
You mean like a README?
Yeah, I mean README only, but README which has the logs of your commits, the comments basically. The
you mean the change logs?
Yeah.
Okay, yeah.
Or you can dump it somewhere. I don't know.
That's a good point. I'll come to that. So there is something which Angular as a company came up with called conventional commits, which allows you to auto-generate change logs on the fly from your Git history. So that if you're shipping your product to a customer and you see those nice change logs, you can auto-generate it from your Git history. I'll come to that. So basically, you don't have to do it separately, manually. The whole idea of this process workflow, which is supposed to be covered, I don't know how long it will take. We might overshoot on time, because it's a discussion session, so it'll overshoot. The whole idea of this whole policy and processes workflow is that you should do minimal amount of work, and all the servers which are powering up and whirring around, they should do the maximum work. Okay, so anything that you can automate, script, and so on, including generating changelogs, we will automate, script. We won't write it ourselves. And since it is automated, it can always be regenerated given a state of the repository, so you don't need to commit it also per se. Okay, just give me 1 minute. I have to shift from the conference room to one of the cubicles because there's a meeting here. Just give me 2 minutes.
Hey, Delia, you said commit, sorry, -m and -a, right? I'll open a file.
Yeah, it will open a file and there you can write things. So initially you can write, and after below that it may give it its own commented few things like changed files,
Okay.
right? So you can perhaps go to individual files, write like whatever you want to write, like for so and so thing changed in that file, or you can just in the beginning you can mention, okay, there is a so and so algorithmic change we have done, and that's it. You may not go to other individual file names.
Okay, so anything else you want to mention, comment on? Okay, fine, please carry on. Then, okay, so this was the basics of git clone, add, commit, push. Now the next step is, now that you are starting to use the command line. By the way, as you have noticed, my choice of editor is Vim, and my choice of doing all this push-pull business is the command line itself. Instead, if you have VS Code, for example, then you can do all these things. Sorry, I don't use it usually. That's why it's a bit rusty. You can open up the folder and you can see. I have no idea what this is. Okay. Yeah, as you can see, it has already directed. It's part of repo, GitLab Git repo, and it says that there is one extra commit which has not been pushed. So usually you click on this recycle button to synchronize essentially, and you can go here and check what are the changes that have been made or commits like staged and all those things. So for VS Code, we can do a separate session, but I'm not the I'm not the expert to comment on those things. So we'll find someone for you. So okay. Now,
Just as extra comment, so if so you said that you are using Vim, so I use it. I mostly on my local laptop I use Gedit or something like that. So, but you can like Vim has a lot of functionality that are new functionalities can be added. Yeah, customized functionalities. So you can, if you have, if you know those, or if you're using those, you can just mention that as well on the fly.
Okay. Well, I don't use much of those fancy 3-4 keys combinations, but okay, fine. Whenever we see, or if you see me using something weird, just let me know. I'll explain. Okay.
Okay.
Because yeah, means whatever I use on a daily basis, only that much I remember. Others I always have to Google search and so on. Okay. So fine. So we are basically on our way to creating a terminal code. This is not the code we wanted. So now we'll start changing. So now that you have seen the basics of push, pull, and so like you can push, if you made a change, let's do that once quickly. So basically, suppose now there are multiple people working on the same project. So suppose I myself make a change in some Git repo, somewhere the same Git repo cloned onto some other machine, or suppose I make a small change here itself. Like for example, in the README, I say it should be called thermal solver instead of just thermal. And I change it here. So this is 100 solver. Then the way you synchronize your local repositories with the changes that have been made online is you go inside your repo and call git pull. So as you can see, it will pull. Oh, I have to merge. Yeah, so you'll call git pull like this. This should not have happened because there's a reason why this happened, because there was one unpushed commit here and there was one commit there, so you have to merge and all. We'll come to merging soon. But this is the basic thing. So it's always a good idea when you are resuming working on a repo which is there on your local machine. Either you can, when you usually work, either you can just push and remove the repo so that everything that you made, all the changes you made are there online. And next time you want to work, you can git clone it afresh. Or if you like to preserve your local repos and not delete them, then always do git pull after if you have been away from your desk for maybe 1 hour, 2 hours, because in that time someone else might have changed some other portion of the code and you want to keep it in sync with your repo. So always try to do git pull. So yeah, so that's push, pull, and so on. Now suppose, so let's quickly see what all changes have been made. So there's nothing much as of now. Let's push this once. Okay. So as you can see, what has happened is, okay, we'll come to this. This was not supposed to happen. This makes the graph look a bit complicated. Now suppose you're trying to develop the solver or some feature that someone has asked you to do. The ideal way to do that is to not start coding right away. Okay, means that is what we are usually used to, that someone has asked us to code something, we'll code something. Usually after a lot of coding disasters, you will figure out that some problems are unsolvable by the problem statement itself. So it's better to just decide that on the face of it rather than first try to code it and then realize that it is not worth doing and so on. So usually for these discussions, before you even touch coding or start coding for a problem, you have something called issues. Issues are your friend. Like, people hate issues usually, but in GitLab, issues are the best things that are available, because you can create a new, you can always tell someone who is requesting a feature from you saying that create an issue. Unless you create an issue, I won't even discuss this problem with you. Okay, so they will go and say, okay, can you please add Laplacian step for update and so on. And they'll assign it to you or something, put a milestone, will come to milestones, enables, and so on. So you create an issue and then you can keep discussing what is a Laplacian like problems. Okay. So you can keep on going on like this, and then finally, suppose you see on Wikipedia, and then someone links to it and says implement this. Okay, so now you have a problem statement which basically tells you that you have to implement this equation, this particular equation, the finite difference version of it. Okay, I don't think they have a finite difference version here. Wow, so many integrals, no finite difference. This is the problem with numerical computing. Okay, fine. We'll write our own finite difference version. So then what you do is, From it, it's always good to create a branch for every new feature that you're developing. So the way you create a branch is, the simplest way is you can go to your repo and you can create a branch from here, a new branch. So essentially what you do is, from your main master repo, master branch, which is this main thing that you have here, you usually branch out and do all your small code modifications there. And when you're happy with the modifications, it works and all, you can merge it back to your main or master branch. What it helps in is, when you're doing the experimentation and development and so on, the main repo is not getting updated with possibly intermediate and breakable changes. So it is, whenever you're working on something, it's always a good idea to freeze to treat the main branch as a client release, production release kind of thing, like very sacred, and you shouldn't even disturb it and things like that. Actually, okay, fine. So you shouldn't disturb it and so on. So one way to self-enforce this rule is, at least this is what I do usually, is when you create a repo, or when someone has created a repo for you, always ensure that someone said something. No? Oh. So you always go to protected branches here and say that who is allowed to push to the main branch? No one. Okay, so that way no one will be able to make direct changes on main, even if you're the owner of the branch. Okay, owner of the project and so on. Okay, so you'll always have to branch out, make changes in the branch, and then merge back to the main branch. So that way your main branch remains very clean and like functional and production level and so on. So should I show how it fails? Basically, you can do a git commit here on the main branch and try to git push. It will say not you don't have permission to push or something. So what we'll do now, since we have locked our main branch like this to direct pushes, we will do indirect pushes by first creating a branch. So we can create a new branch like this, a branch name called, suppose, add Laplacian. I think branch names can't contain spaces, so dash. Okay, create a branch. And now, since I've made a change in the remote repo, you always do a git pull. So as you can see, it has created, brought in the new branch to the local machine also. And now you can do a git checkout. So you can first see which branch you're on. You're still on main, but you want to move to Laplacian now. Then you check out. I think switch also works, but usually people use checkout. Yeah. Add Laplacian. So now you are on the add Laplacian branch. So now suppose you can, and as you can see, your old files are now here as well. So it has basically made a clone of the same files in the branch, and you have this. So now, okay, from here to Laplacian is not a small conceptual increment. We'll go ahead step by step. So the first thing we can do is we can say, okay, fine, let this num be there. We'll start off with the double array, 2D, 10 by 10 array. So, and we comment. Okay, this is a very ridiculously small change, but just to show you, I'm just commenting add array. There are wars being fought online in Reddit and other forums about whether you should use some blah blah verb versus blah blah verb. Is it add versus added and so on? It's up to you. Usually I use add because I think, again, Torvalds was very opinionated, said that you should treat git commits as layers of patches being applied on top of your base initial commit to create software. So it's like an instruction to the person that if you take the first commit in the entire history of Git, and then you're applying one more commit or checking out one more commit from there, what did it do? No, what are you doing? No, the correct way to phrase it would be, okay, so basically each commit is like a layer which adds this thing or changes this thing or fixes this thing and so on. So you're saying it as add array and so on. It's like an instruction to the person and so on. So add array. Oh, sorry. Yeah, see, this is the thing. Git add first and then commit, or git -am if you want. I will push this. So the reason I did all this nakra was just to show you how the graph looks usually. So as you can see, we started with the initial commit. Forget about this green branch for now, just mentally forget it. It goes straight up, and then you have small this Laplacian branch going out of it. It doesn't look like a branch, it looks like part of master only. That is because the master branch is still at this point. If you really want to see whether it is branched out or not, what you can do is you can go back to master, but I can't change master. So what we'll do is we'll create another branch. Or I can just show you how it looks in a real thing. That will suffice it, I hope. Yeah, this is too linear. Does anyone have any really messy Git graph in their repos? I don't know. Let's see. Like we use it so safely, it looks very clean. Oh God, everything is clean. Okay, fine.
Check data fetching. There's a lot of merge conflict going on there. And
Where?
data fetching on this cardio group.
Where is it?
FFR? No, go back.
No? Okay. Oh, this
Okay,
one.
I'm not sure the group.
Is it called data fetching?
Yeah.
Oh, sorry. Graph. Nice. Oh, okay. This is proper Git. So yeah. So as you can see, this is actually this is not even that bad. You should look at Windows kernels and so on. It's like a full banyan tree. So yeah. So basically, you can merge you can branch out from a branch and then merge back and forth and so on and so forth. So this is how a very busy GitLab repo will look like, essentially. Okay, so this is the medium scope of Git. The full scope of Git you can find online, like how actual real world big repos look like, the history of them. So that was the graph part. And now what we'll do is, the reason I created the branch from here was just to show you what a branch conceptually is. But usually we prefer not to create branches directly. Like, why are you branching out or trying to write a code without any reason? That's the first question your manager or your people will ask during your performance or review and all those things. Why do you keep coding when no one had asked you to? So usually, always make it a rule that you code or branch out only from an issue. Like if there is no issue, create an issue and then branch out from that, but always branch out from an issue. The way you branch out from an issue is you don't branch out directly like that. So what you can do is, for now, I'll just go to this branch and delete it. It's like an orphaned branch. I'll just randomly delete this branch. Gone. Okay. If you delete a branch, it won't come back, huh? Unless it is merged or... Wait. I don't know. We have to check the git log once. So right now, it won't show any branch. So usually, you always create an issue. Or if someone has created an issue for you, you always branch out from there. So as you can see, here are two options in this drop-down button. One is create merge request and branch, and there's only branch. For now, we'll just create a branch from here. From where? From the main branch to what? To this name. And it has nicely automatically put a number in front, which basically is the number of your issue. So that you always have a nice correlation or mapping between your branch and the issue, like this. So it's branch ID, issue ID dash your branch name, which is actually the name of the issue also. So just keep a note that special characters in the issue name will translate to blanks in the branch name. So if you write C++, it will just write C here. So that's a scope of confusion. But apart from that, it's a pretty automated way. So you create a branch here. And it's almost the same. So as you can see, now it has a main and this thing. So again, what you can do is you can do git, first see for which branch you're on idle question. If you do a git pull, it fetch the new branch, but it won't delete the old branch because it's a local branch. It's just not related to any remote branch because there is no remote branch called add Laplacian anymore in the online, this web server. Okay. So you can just do a git branch, git checkout of one. And you are in this branch. So now you can start working on whatever was asked in the issue. So what was the issue? This new GitLab update has screwed up the clicking part on the UI buttons. So just ignore that for some time till they issue a patch. Yeah, so the heat equation, we were trying to figure it out. So usually heat equation, blah, blah, you have, so remember, since we deleted that old branch and this is a new branch completely unrelated, that array is not there anymore here. So you have to create it again. So you'll create a array. Let's call it 12 because you'll need 2 padding points on the sides. I'll initialize it with the x0.
I have a small question. So is it really like mandatory to when you merge, you always delete the source branch?
Not mandatory. It's just that if you don't, there will be so many dangling branches. Actually, let's go to GitHub. That's a very good question.
Because I just want to know in some, is there any use case where we still do something like we also maintain the source branch and while merging the master?
Yeah. So basically for continuous development, where suppose you have been given a very conceptually hard problem to solve, which has multiple steps, and the client has told you, or rather, let's look at it like this: like you branched out, you wanted to merge, but then you realize that this problem is not solved yet. I can give a temporary fix or patch into the main code from my branch, but I need to keep working on it still. So then you merge the branch, but then you keep continuing developing on your branch, and then keep merging it again when you have some more feature in your branch. So basically, this is for cases where suppose you're not using, you don't have a clear idea of what to call an issue and where to like modularize the issues and so on. So it's not a separate branch for each issue. You're just, yeah. So basically, you can keep maintaining the branch. It's not a problem. Just that if you really are done with the work in that branch, it's best to delete, because if everyone starts dangling their branches around, then it will be a complete forest. Okay. If you look at the graph, it will be just, or basically if you just scroll down here, it will be like hundreds of branches lying around here. So it will be very difficult to. The reason I pulled up GitHub is because I wanted to show some very good examples of places where people don't delete branches and what happens. Or maybe trending. Let's go to trending ones. Trending ones basically get slumped by so many. Okay. Let's see. This looks fancy. No, this is also good. Too many people are writing clean code nowadays. That is the problem. See, nothing. And it's trending with one issue. Wow. Okay. Okay, we'll get to dirty repos later on. Then find it. So.
And one thing I have another question. So suppose by mistake, so while you merge, you did some mistake, which is otherwise it's fine, but you have done some mistakes which like it's not like algorithmically incorrect, but some other way it's incorrect, and you realize later after the merging. So is there any like kind of a rollback version for masters, or you have to do another issue, create another issue, and then rectify it and then merge?
So you're saying that you have, okay, let's see, let's take an example. Like you're saying you already developed in a branch and then merged the branch into master, and then when you're running the code from the master, you realize there is a problem. Is it?
Yeah. So earlier it was okay. And suppose you do some code test, it passed through both of them, but you realize, okay, this was earlier it was okay, but now, so should I create a new issue and then rectify it, or we can roll back to that previous version?
Okay, so
in master itself.
Understood. So since you said that it earlier in the development and the merging part also it passed the tests, and only during actually running the code you realized it has an issue, then there are two things to note. We'll come to this again. One is that means there were issues which were not sufficiently captured by the current set of unit tests. So then you have to add one more unit test. That is one thing. The second thing is, this is a classic example of a bug. Like there is no like, arguing about this. This is what even marketing people will call there's a bug in the product. When you finally in the production run itself, there is an issue. So usually you create an issue. Okay, means there is nothing to roll back and so on. It's a bug fix. So I think this is a good time to show you what an ideal Git workflow looks like. So there are things management people keep coming up with these terms usually, but I will share the links to all these things. Actually, all these things are there already. Actually, this whole discussion that we are having is sort of captured a bit in, if you go to this particular repo, it's an open repo, systems. It was previously called HPC operations, now it's called systems. There are a lot of tips and tricks shown here. So using GitLab, if you go to, you will see a few things here and there. A good Git workflow, actually, I didn't put it here because I didn't want to confuse people, but okay. So I'll put that link here. So this is a good Git workflow that some companies used to use. As you can see, it was published in 2010. But in 2020, the author says that there has been a lot of argument on this, and it's everyone's personal choice. He's not enforcing it on anyone, and so on. So this is how it looks like. We'll go through it if you really want to go into the depths of it. It gives you a good idea of how people use Git in a professional manner. But this is not what we use because this is a bit of an overkill for the kind of size of problems we have right now. This is good if you have 10,000 files with 200 million lines of code and thousands of developers working simultaneously. Then it makes sense. For a company of this size, it's an overkill. You can still use it, it's fancy, but this gives you a nice idea of what all models of branching, merging, and bug fixing and all you can do, and so on. So the reason I brought this up is you can see that people use these intermediate branches called hotfixes, which are like on production. If you suddenly find a branch and it is absolutely crucial, you put a hotfix, and then there are bug fix branches also, and so on. We'll come to those when time comes. These are called hotfix branches. Yeah, bug fix is the same in this lingo. So yeah, this is the rough picture that you have to, like how it looks like, the Git graphs. So now coming back to our original issue, which we had to quickly close, we'll add an array. We'll not add the Laplacian right now. We'll just initialize the array. Okay. So as you can see, I'm on my way to keep putting a let's say we're initializing everything to 100. Okay. So let's put branch. So initialize heat. So we push, and you can see that the branch has come up here. Okay, so we have it here. Now there is one small thing that you can do to keep track. Again, this just to keep the audit people happy. But it's also a good thing to see, like pat yourself on the back if you see something like this. This is called GitLab's value stream, which basically shows what is the time taken by you in different stages of this whole Git workflow. It has different stages like issue, plan, code, and so on. You can see what they actually mean. I'll show you how it looks like in a big repo, or a repo where things are continuously being pushed or coded. Where is it? Analytics. So this is what it looks like. It'll just give a, why is it showing so little? Okay. Yeah. So it interestingly, it shows that it doesn't have an updated show code itself, because it classifies the stage of code in a certain sense. We'll come to that. So if you want to gather analytics data like this, the only thing you have to do is just remember this. When you are doing a comment, so let me just do a minor change here, which is BC temperature. So what we'll do is we'll do a hot plate with the Dirichlet boundary condition on all sides at 100 degrees. So if I want to maintain the temperature at 100 degrees on the padding points, I just need to initialize or update the bulk points. So I'll just initialize the bulk points to some other temperature, and we'll update only in the bulk. Let's call it 0. Okay, so this will be bulk temperature. And then we'll do update here. Update on the bulk. So if I now do comment -m, mistake. This is the mistake I was trying to show. So if you do something like this, just git commit and push. If you go to the issue that you have corresponding to this particular thing, you'll just see that there's a branch being created, but there's no other information going on. Already I pushed one comment online, but still there's no mention or relation to the issue. Only if you go into the commit, you will see that, okay, there has been some, or if you go to the graph and all, you'll see there have been comments and so on. So how do you keep telling so if someone is reading the issue, they don't have any idea of what is the status right now of this problem, unless they actually track down the graph for this comment and so on. So just to keep it in the same page and also to help you gather analytics like this, whenever you write a commit message or the first commit message you write for the issue, or actually for every commit message, it's also always a good idea to tag the branch, the issue itself. So you can call it C issue number 1 or C issue number 1. Yeah, issue number 1. So this hash symbol is meant, it's GitLab's way of identifying issues. Dollar, I think, is merge, or exclamation is merge request. Dollar, I think, is something else. Something, yeah. So hash is issue and issue number 1. If you do something like this, or you can just say hash 1 also. So if you do something like this, first of all, it will say that it's already been committed. There's nothing to commit. So I have to basically edit this commit and make it 1. How do you edit a commit which you have message you have already made? What you can do is you can say git commit -- amend -m your new message. So here I can push. It will say now it's this message. So if you go to git log, you will see that it actually has that commit message. Okay. Now if I do git push, you'll see that it showed up here now. So now people can see that, okay, you're committing. Okay, you're working on it actually, you're not goofing off just now, and so on. Okay, and the actual use of this is basically the value stream. So right now it won't show, it will take a bit of time to gather data, maybe over 2 days time, maybe last 7 days, no, still no data. So if you keep doing this for 2-3 days, slowly this will start doing analysis on that, and then you'll see mean time for in the issue phase, in the plan phase, code phase, and so on. And then if you're into management tactics and strategies and all those things, MBA type stuff, then you can make a full philosophy out of that. This just as a side track. This is not relevant to anything that we do here.
Issue number is repo-wise, right?
Yes.
And there could be an issue that we are solving that like that spans over multiple.
Okay, yeah, I'll show you. So usually what we do is in GitLab, you link issue. So if you want to see, I don't know if you can comment by putting the entire URL of an issue. Do you want to try that? Let's try that once, because this whole session is meant for trying only. So let's take a public issue, like for example, okay, I don't want to mess with.
We can, I think we can put URL of another saying and just link it to some word.
So let's see. So let's do Clang format here. So this was the repo where we last did the same kind of lesson. So let's do issue 1 of this. So we will make a small change. We'll call it nostalgia because we are linking back to the old camp issue, and we'll call it same. And like this. This is a separate repo. Both are public, so it shouldn't be a problem. Let's see if that issue picks up. Oh, nice. Yeah, it does. This I didn't know. This I learned. Nice. Okay. So yes, you can span across repos then. But I think just you need to make sure that you have permission to comment on this repo or something. That permission thing has to be there. But otherwise, yes. So it seems like GitLab takes care of that nicely.
Okay.
Fine. Yeah.
I have a question. So suppose I'm supposed to finish a couple of issues, and assuming that for every issue I branch out and then merge. So like if I branch out for first issue, let's say branch 1, and then I commit, but I am holding on for a day or so maybe because I'm supposed to like discuss it with someone and then merge it.
Yeah.
But in the meanwhile, I also want to start working on some other issue.
Yeah.
So what is the best way to do? Because I have come across merge conflicts many times.
Yeah, so that's the thing. You have to resolve merge conflicts. Merge conflicts, resolving them might seem a bit tedious. If like, okay, fine. If we go through it once, then we can see how quickly we can do stuff, because there are things called git merge tools. Merge tool. So if you open, okay, there's nothing here because right now there are no merges open. Sorry. You can choose your tool also here. So we'll use git merge tool to do a merge conflict resolution. Or if you don't want to go into the complications of this git merge tool, you can do a merge conflict on the GitLab UI itself. That's cleaner, or that's more visually user friendly. So okay, fine. We'll go through merge. That is the typical or ideal situation for doing a merge conflict resolution. So there is no two way about it. Like, it's not, you can parallelly branch out as many issues you want. Although, like, from that, what is that called? That philosophy? Scrum. From that perspective, I think usually it's recommended you have only one or two issues open at a given time on your plate or something. So ideally that will restrict the number of issues, but Git doesn't have any problem with that. You can have as many number of parallel issues open in Git as you want.
So I also sometimes it occurs to me like I have like 2-3 problems, and I open one my new branch, and then I do something, and simultaneously I open another branch, so that before committing the first branch. So what happens? So sometimes then when you merge with the master.
Yeah.
Okay, but the second branch is still the previous version, right? As compared to the master right now.
Yes.
So what I do then for the next branch, what I do, a merge branch with the previous branch, and then merge it to the master. Is it a correct way to do that?
Okay, let me see. So you have branched out from master, and then did you branch out from this branch, or you branched out separately from master again?
Master again. So not from this branch. So yeah, I created two parallel branches from the master, and one I have already committed and merged the master. But now I want to proceed with the next problem which already I have created. So that's what I do, actually merge the previous branch with the current branch to avoid this conflict. Is it the correct way to do that, or should I do it differently?
Yeah, so let me quickly, there's a Jamboard or something like that, but okay, fine, we'll use this only. Just to get your idea, you have master, and then you have, this is going to be really hard. Okay, you have one branch and then one more branch going out. And now you have updated this one, suppose, and you have branched in to master back.
Yeah.
So this is still the old one, huh?
Yeah.
Now your question is, how do you merge it? Do you merge it first here and then branch, or do you merge? You can directly merge to master. That's not an issue. Yeah. So basically,
now if there is something like the two files are actually whatever merging I have done in the first branch, same files I am actually going to modify something else, and then again.
Yeah.
So in that case,
it will create a merge conflict, which most probably, if they are in different locations, or actually GitLab's UI tool for resolving merge conflicts is actually pretty good. It is able to figure out what is new in this branch, what is new in this branch, or basically master right now, what is new in master. So let's draw it here then. So you're about to merge here, and master has become the new branch here. Right. So okay, so basically this is the place where this merge conflict is supposed to happen. So So usually GitLab itself will tell you, okay, look, the same file, there are some change. This branch says that main.cpp line number 30 is int a, but your this branch line number 30 main.cpp says double a. So what should I keep? Right? GitLab, once we come across merge requests in GitLab UI, I'll show, like, they will give a keep theirs or use theirs, use ours, or do your own combined edit kind of option. Okay. So basically you get to keep either this branch itself and discard all changes in that file from this branch, or you keep the changes from this branch and discard the changes from master, or overwrite the changes of master, or you get to manually write your own combined code in that small region also during that merge request resolution. So we'll come across that. So we can do it right now, actually. Let's do that. So we'll quickly finish off this. But yes, if you do a merge request resolution, you can directly branch into master. No need to branch it first here and then branch it back here. So means that won't do anything much helpful. Means it's okay. Means it's not wrong. It's just that it won't help you in any way. Yeah, more than means you'll again go into conflict with this merge resolution problem. Yeah. Okay. So we will check that once with an example. So we have main.cpp. Fine, here's a good idea. What we'll do is we'll delete nostalgia because we don't need that here. And we'll delete string also because technically we don't need string. So in this branch, I think let's do this. Since we have double here, like this is the current code in this branch called please add Laplacian. Suppose some genius comes and says that using double is an unnecessary waste of memory because it takes 64 bits. We will use float, which takes 32 bits. So they'll see this and they will say, no, this add Laplacian is not the main concern right now. We will use float instead of double. Okay. Now you were supposed to write a Laplacian code there, and suddenly this urgent request has come. So basically this guy has said that urgent. Please start using warning, yeah, something. Please use emojis that make issues more colorful and nicer to read. So someone says this is urgent, and by tonight I want this. Change to float right away. So what you do is you create another branch as you would. This is branch number 2. And then in this code, as you can see, it was still the previous code. There was no Laplacian here because I have branched out from master. Did you see where this problem happened? So when I created this, by default, it always goes into main. Ideally, what I should have done is I should have taken it from that other branch number 1, and branched out from that branch, change it to float, merge it back to 1. But okay, fine. For showing the conflict resolution problem that Biplav was talking about, suppose we have done something like this. We have branched out from main only. And we are going to do a git pull here, which will show me that I have a new branch. Sorry, I have to make changes to this. Then I will need your help now. How do you do git reset? Minus hard, is it?
Yeah.
Oh, sorry. What is it? Minus hard or small? Okay, okay. Thanks. Yes. So, by the way, I did it so fast I forgot to stop. And is everyone familiar with git reset or understood what went on here? So essentially, I had an unadded or uncommitted change in this file, which was I had deleted. Okay, let's redo it again. This is like this graph is going to look very bonkers. Like what? That's Looper movie. Notebook, is it? No, something. Anyway, so I deleted this and I forgot to add and commit and push the changes. So essentially, there were uncommitted or unstaged changes here. And then I wanted to do a git checkout to another branch like this. That's why it said, please commit your changes or stash them before you switch branches. there are two things you can do. You can change branches without even committing. So what you do is the temporary changes that you have made, Git will locally on your desk or laptop or desktop keep the modifications. So you just do git stash. It will just create a temporary working directory somewhere and temporarily save the changed but uncommitted and unstaged code changes there. And then you can do a git checkout. Oh, sorry. And suppose then you make changes here and then push and so on, and now you want to come back to the first branch. So then you can just do git checkout. And if you now do git status, you will see that your, hey, what happened? Where, how do I get back the stash? Oh no. Yeah, how do I get back the stash? This is sad. I've never used git stash in the last 5 years.
There's one more problem I come across. So basically, on my local, after merging the previous branch, when I have to start, so I pull the new branch, but I forget to check out to the new branch. So I keep making changes in the old branch, which is probably already merged and deleted on the remote.
Yeah.
So
what you usually do is you immediately from that stage where you are, that very messy stage where you find yourself in, you will create a branch from your current thing. Means currently you'll add commit, whatever it takes to make it stop giving you warnings. Branch out from there. Basically on the fly you're creating a new branch and then you'll keep working on that branch.
But that branch is deleted on the...
Yes, on the remote, right?
On the remote, yeah.
But you can, on local, it is still alive, right?
Yeah.
So just what you do is, you, from the, from the local branch itself, you do a grid branch. Okay. And create a new branch called fixing some issue, something. Fixing this branching problem and so on. Or we can actually come across, just remind me to demonstrate this once. We'll do that because that is a very common use case, yes. Yeah. Thanks, Nitin, for the pop heads up. So this is the, now you're back to the working version of your first branch. So what we were trying to do is, we were trying to, just to quickly finish this off because I think we are going to overshoot time like anything. We were doing a double in this branch because this is branch 1. And then we have float requirement in branch 2. So fine. We'll just get back to git stash, git checkout. We'll convert things to float there in git checkout 2. We'll convert things to float here. This. To make my life simpler, I'll just copy paste the code, whatever was there. Let's leave it at that. Let's see what merge. So basically what has happened is, in branch 2, I have a code with float t1212. In branch 1, I have a code with this thing, double. So I'll add this branch and push, add float. And now check out branch 1, git stash. The main branch here, and we will just commit these changes. Okay, so now we have a very nice situation here on our repo where we have 3 branches alive. One is main, one is use float, one is use double. So if you look at the graph here, it looks like this. So main is here. From there, we have branched out to float, and there's one branch going to double, 1 and 2, like this. Now we will try to merge both of them to main. So what we'll do is how to do merge. You can do it from the command line, but we'll go through a process called code review. So for that purpose, I want to do it from GitLab UI itself. So what you do is you create a merge request. So call it a new merge request. You select your source branch, what you want to merge, and target branches to where you want to merge. Okay. So suppose I want to first merge the double walla version into main, hoping there won't be any conflicts. If there's conflict here only, then okay, we'll start here only. Usually the default things that are given here are sufficient. If you want some particular person to see your merge request and comment on it if the code is correct or not, you can assign reviewers and those things. I think currently GitLab supports only one reviewer branch per issue or per branch merge request. In the starter version, I don't know if it's more than that in the premium versions or so on. And you can delete your source branch or keep it as you wish. I think we'll keep it here because we are going to add the Laplacian. So this is just for time being. We are merging. You can approve, not approve, depends on whether you need approval or not, and then merge. So if the button here is green, then it means it can be merged. So GitLab says there are no conflicts. Okay, you can merge. Now we will. So now we again have 3 branches, and if you look at the graph here, you will see that branch 1, which is the green one here, has merged with main, and branch 2 is floating still. So now we will try to merge this purple branch 2 into main, and hoping that there will be a merge conflict. But nowadays GitLab is very smart. It is able to figure out if there are merge conflicts. Let's see. So again, we'll try to do it to main. Same thing. This we will delete the branch, okay, if it goes through. Ah, very nice. So it says there are merge conflicts. You can try to do merge locally, or you can use GitLab's very nice UI-based merge resolution tool called resolve conflicts. Let's see how to resolve conflicts. It says in branch 1, which is here, the changes are changes. So basically R means the branch you are on and trying to merge into the target branch. So R changes are float. But this main wala branch, it says it is double. What should I do? It is asking you. Should I keep use R's, which is float, use theirs? Or do you want to do some edit inline business where you say it is float if machine is this and double if machine is that? So usually what you do is you can, okay, the simplest thing is you can click use R's, then it will just overwrite this double with this thing, or use theirs, then it will ignore this thing. Edit inline is a bit more complicated in the sense that you will see these small markers that are there, this arrows and dashes. What this means is this is where the conflict is. You decide how you want to modify and bring this file to a compilable state. Okay, so you go in and see where all these arrows are. You start deleting them to make it, because C this is not C++ syntax, so C will throw an error if you commit with this weird arrows. So suppose I say that I decide it's neither float nor double, it's int. Okay, so I can do that actually. Right. So the edit inline feature allows you to decide in conflict zones how you want to act out your stuff. Okay, fine. Let's not. And this is your default commit message. You can change it also. Like I resolved a conflict which had severe implications on bit size, memory size, and all those things. Then commit to source branch. Okay. This is for the entire commit. So you can go back to interactive mode, and inline also you can see what are the changes. There are multiple options. You can play around with these things in a repo. So now, okay, just 1 minute. So it still says there are merge conflicts. Okay, I don't know why it says that. Let's figure that out slowly. So so we'll try to merge locally. So it gives you the instructions how to do that. Okay, so it says fetch origin, basically git pull, and then you check out the branch like this, review the changes. Like basically you check out the second branch. This is just they give a very big syntactically pure way of doing things, but the shorthand versions are the ones which we are using. This basically says git pull and git checkout branch 2. That's it. Review the changes locally, and then you check out main branch, and then you git merge. So basically this is all you have to do essentially. So let's go by it step by step, since GitLab was half useful. We'll try to do the remaining ourselves. So the first thing is git pull. So which one do you have? Git pull. It will take in the half merge resolution that we have done there. Okay, and update the keep a merge request here also. We'll do git pull. And git pull is done. Check out branch 2. Yes. Let's see. Nothing to comment. Everything is fine. Okay. Then we will git pull. Or it's already git pull, so nothing. Now we'll do get checkout main. Status or git pull again, just to see if there are any changes. There will be changes. Status. So basically, we have now synchronized both the main and the branch 2 from the online versions. Now we'll do the manual local merge conflict, which seems to be the hardest part, but actually it's not that much. This was the only thing. So when you did that git merge no fast forward, we'll come to it later. It's a unnecessary technical thing right now. So it says that the update was merge branch this thing into main. So this is the merge that we manually resolved, right, online. So this message comes up. So I said, okay, fine. Why are you telling me this? So I'll just save it and quit WQ. Then it will say already update merge made by recursive strategy. So now if you see git status, it says it's completely fine. Now you can git push. Oh. Wait. This is sad. It's so sad. Oh, do you realize what happened here? We had very nicely promised ourselves we will not push into master. And then we basically shot ourselves in the foot like this. So what we'll do is, this is going to be seem a bit complicated, but it's not that much. Let's go to the graph. It will be easier to explain there. So right now we are here, which is we are trying to merge into master, but because we made some changes here, it got screwed up. Okay. So what we'll do is we'll git checkout to 2. Essentially what we'll do is we'll take the master branch here, we'll pull it into 2 and then merge 2 into master. That way we're not directly trying to commit to master. Or what you can do is you can also git checkout 2 and I think that's simpler. So git status, this is fine. This is push if you do, that's also fine. Let's see in our merge requests. So we'll do a git pull into git merge. Let's use the reverse syntax now. We're in 2 rect. So basically what we did was we pulled master into 2, merged it here, and now we'll push it back to main. This was unnecessarily complicated because we promised ourselves we won't push directly to main. These are like side effects of trying to do things in a fancy way and shooting yourself in the foot. Okay. And now we can go back here. And now we can nicely see it is mergeable. Since this is a comment issue 2, which says float instead of double, and we are not very keen on using float, we'll delete the source branch. No problem of using that again, and we'll merge. Okay, it was merged. Now let's see the graph. This graph is going to look nice. So Mrunal, I think now this graph is trying to look like what you had showed. Yeah. Yeah. Okay, so this is how this is called merge resolution. As you can, truly people are scared of this because what merges where and what conflicts come where. But actually, the tools which you saw right now, just resolving conflicts, like doing the diff, basically, what changed here, what changed there, ours versus theirs, or your own inline editing, and then figuring out which branch to merge into what. So these are the only two tools you need to use to resolve all these merge conflict strategies, merge conflicts. There are other advanced tools you can use. What was the equivalent of the GUI thing there? It's available if you do git merge tool here. Again, it won't show it here. Let's see. I think it will come only when no files need merging. So only when you have a merge, because next time if a merge conflict comes, we'll do it using merge tool. Okay. It's basically a command line version, a Vim version of the GUI tool that you use there. It also shows use ours, use theirs, or inline editing, and so on. Okay. So this is it. Can we just take a quick look at just 1 minute? For some reason, my battery is out of charge. Let me just take a quick look at where we stand on the schedule and timing thing. We have issues sort of covered. We'll come to a few more things. Milestones library. Oh my God, we're running 1 hour late. Okay, doesn't matter. We'll make up for it. There are enough question answer sessions which are going on there. So we'll cover milestones and labels and code review. Okay. Any questions about these things? I'm pretty sure this merge conflict resolution business has left many people confused. It's my bad. Or it's actually merge conflict. The nature of things is like that, what to do. But maybe if we keep doing these things again and again, a pattern will emerge and it will become clearer. So let's intentionally keep conflicting stuff. We'll do that. Okay. Now coming to issues, the main things which I wanted to talk about. Okay. So one thing is when you do merges from branches, like the ones we did here. So what are merged right now? This resolve and add float array and so on. There was a comment here which says closes number 2. If this comment is there, when the merge happens, your issue will automatically get closed. You don't have to go and manually close your issue again. Okay. So as you can see in the issues, suddenly these 2 issues are closed, and you will see that they have been closed by the merge request that was merged 3 minutes ago. So that's another nice thing of using merge requests. Now, the thing is that other issue, which was please add Laplacian, we said we won't delete the branch, which is true because that branch is not deleted right now. It's still there. The branch number 2 is deleted because we chose that in the merge. Although the branch is there, the issue is closed. So usually for merge requests where you are planning to keep the branch alive, you usually don't put that. Where was that? So for example, here it says closes number 1. You just remove this default message of closes that issue number. Then it will not automatically close the issue. So this is like a script trigger for GitLab to close that issue, which is there. This closes word and hash issue number. So what we'll do is we'll open this issue back up again because we have a lot of things to do. Reopen issue. Now, since we are going over time, now is a good time to introduce the concept of time handling in GitLab. Some of you might have received an email saying that for every new issue that you are given, give an estimate of what time you think this issue will take to solve and so on. How you estimate or what you estimate is your problem because I am very bad at estimating time. Usually whatever I estimate, I'm off by 2x or by like half x or something. So anyway, suppose I say it will take 1 hour for me. Okay, so I put an estimate like this. There are many other commands which you can use here in the comment itself to do a lot of things. Time estimate is one thing. So this is the estimate of what you think the total issue will take. As you can see, time tracking has said estimate 1 hour here. Now, or you can say estimate 30 minutes also. It will change the time to 30 minutes now and so on. Now, suppose you want to add on top of that, then add estimate. Okay, add you can't. You have to just basically manually set the absolute time taken. But if you want to also log how many small windows of work you did, then you can just keep adding spent. I spent how many? We spent more than 1.5 hours, but we'll say suppose 10 minutes. Then nicely, it will show you that, okay, out of the 30 minutes, you have spent 10 minutes and you have 20 minutes remaining. There's nothing, no one will freeze your account if you go over time or below time and so on. This is just like for your visual sake, like, okay, how close is the deadline and all those. Similarly, if you're doing a deadline-based task, you consider due date. Usually time tracking is used for more research-oriented projects where you don't have a fixed deadline, but you roughly want to finish it in maybe 1 month, 2 months time and so on. Okay, maybe not 1 month, 2 months, maybe 1 week, 2 week time. And then you keep adding spend. So basically, if I spend talking only, I spend 2 minutes. So I will spend 2 minutes more here. So it will become 12 minutes and so on. Okay. Then, yeah, this is time tracking. And you can also set your deadline-based due dates here. And so that is all about time tracking. We'll come to time tracking in one more combined form in something called a milestone. So now we'll just quickly go out of hardcore coding, not hardcore coding, coding in general, and go into all this management jargons, like milestones and velocity of delivery and all those kind of things. Okay. So usually each project has milestones. Obviously, being an industry, you'll have to have milestones, otherwise no one will pay you. So you can create milestones saying, like, as grand visions. Okay, in 3 months' time, I will like revolutionary heat solver is my milestone. Okay, and put a start date, and maybe by Thursday we'll have it. Okay, you can create them. Someone want to say something when I said revolutionary heat solver and I muted their mic. Maruti, okay.
No, I just wanted to say, hello, which will burn the world.
Okay, fine. So, yeah, we have the milestone ready. Now what we can do is, usually a milestone is a grand vision, and you have smaller tasks building up to that milestone, right? Like which are, like you break down the grand vision into smaller tasks. So Laplacian is obviously a part of that grand vision. So we'll add this issue to the milestone of revolutionary heat solver. So then suppose now we'll do some planning activities. So we can, apart from Laplacian, what do you do? We will do that verify reference temperature. So we'll pick up a point with analytical. We'll try to manually figure out what the temperature should be from like the actual physics equation. And then we'll verify if the code is working fine or not. So we'll come to labels in a while. Just a bit. So we'll create the issue. Okay. So then again, so now that we have created a new issue, what are the things that we usually do? If there is a scope of milestone, which ideally should be, because why are you doing anything without a milestone if you're in the company, in the industry? Like, okay. So assign it to a milestone, or if you don't have a milestone, first create the milestone and then come back and assign the issue to the milestone. Okay. Like have a grand vision, don't have small visions. And put a due date if it's deadline based, if your client is like bothering you a lot. Otherwise, just put a time estimate. This is not deadline based, hopefully. So we'll put a time estimate that this one is a small task. This will take hardly 10 minutes. This one of you can just tell me what the temperature will be at a 12 cross 12 grid with 100 and 0 at 20 time steps. So this is the time taken. Labels usually helps you in the manner which I'm going to show you next. So now that we are starting to build a lot of issues, it's very, this doesn't look like a very useful thing to do. Like just go to the list of issues and see what is open or closed. Then you have to change tabs, like what is open tab, closed tab, all tab, and so on. People who are geared towards management philosophies prefer something called a board. Some people like Agile, some people like Scrum. Some people are inventing their own methods. But the idea is you need to see the whole goal or where your product or your project is going in one shot, like an overview of the entire grand scheme of things. So let's look at grand scheme of things of a library which has been there for some time, quite some time now. If you go to the boards, you will see Oh God, this is sad. There is nothing in doing and review. Let's look at something of the group itself. Okay, that should be there. Okay, so you can see things like this, right? There are open issues, which are 148 open issues, which people are like waiting for. There are issues which are to do, which are like well-defined, which have people assigned, deadlines assigned, time assigned, and so on. There are issues which people are doing. There are issues which have been done and waiting for a review or code review. And there are closed issues. Note there are 330 issues which have been closed compared to 148 which are open, which means we're doing a great job. Okay. So now, how do you create this kind of a board? The easiest way you can create this kind of a board with all these fancy, nice tags, so that you can see at one shot what are the maximum activities which are being performed. So for example, as you can see for the last 1 week, there's been a lot of system administration activities being performed here. And there are a lot of different issues in the other boards. Okay, so the way you do it is you will go to an issue and set labels. So there are multiple labels that you have available to you as part of being, if your project is part of the SS Labs namespace here or SS Labs group here. If you are in your own namespace, you'll have some default labels like to do, doing, or something. And you can create your own labels by going to, where do you labels, project information. So these are the labels I created for my group, because this is the kind of stuff we keep doing usually. Your stuff might be very different. For example, if you're in Aero, you might have a label called acoustics kind of problem or something, acoustics or something, or a paraview or visualization bug or a glitch or something like that. So different groups might have different labels. That's why there's no common set of labels for every. There are a few common set of labels. For example, doing is common, everyone does things, and so on. Feature is also, I think, a common label. Let's see, it's part of Sankhitra, yeah. So it's a common label. But front-end or Genoa or something like that is part of HPC only, because I don't think anyone cares about these things. So like this, if you create labels in your issue, then you can, so what is this? This is analytical. So is there no theory? You don't do theory in this group. That's why there is no, oh, I think there is survey. That is the closest we come to literature review, survey. Or test, yeah, test is a better label for this. So basically now if you put labels like this, you can go to the boards and you can see it's open. Now you can create a new list which says, okay, show me all the labels that are there in, or show me all the issues that are in the doing stage. So you can click the doing label, create a board for the doing issues. And now what you can do is you can drag this issue from here, which was open, to doing. Okay, I won't drag this here because we're not doing this, we are doing this. Okay. So, and then you can create another board or column which says to do. You can reorder them because to do comes before doing, and review and all those things. Like this, you can keep creating. This one is well defined, so we'll put it into like this. So as in when you're doing these changes simultaneously, your labels are also changing. So when I put it in doing, you can see it automatically a doing tag got added to it 30 seconds ago, and so on. So this helps you manage a big project. Okay, so if you look at any client-based or client-facing project, you'll have a lot of issues, a lot of going back and forth into doing and all those things. So this helps you keep a sense of where things are, and it helps you look good in front of the auditors also, because yeah, this is a good time to now that we have been using GitLab for quite some time, this is a good time to request everyone to pay particular attention to this particular graph that is there. Our parent company has very diligent auditors who have asked this question: what happened in this this series of gray areas? Were you on leave? If you're on leave, show me the leave letter. Yeah. So they have let us go by this time because we are a new company and all those, like a naive, doesn't know what to do Git kind of company. Next year, they have said we will be very specific on, like, if there is a long stretch of vacancy in like gray areas, So basically, okay, these dots basically mean activity. So activity means these kind of things: open, close, issues, merge, commit. I think it says issues, merge requests, pushes, and comments. These count towards activities. As you can see, you have comments and issues. If you really, okay, this is a bad idea. Don't quote me on this, but you know, the more the number of comments you make, no one is going to read the comment content per se, but they'll see the number of comments you have made. So you know how to increase your activities. Okay. So, but please don't make it a habit. There are many people on GitHub you'll see making so-called contributions to open source by changing a comma to a full stop and things like that. That is not a contribution. Okay. So,
so which makes like sorry to interrupt. So that means we should at least have a commit per day, isn't it?
If you do that, the Reliance people will send you. Sorry, our parent company people will send you mithai, like that box you got last time.
Okay, that's why I didn't get last time, I feel.
Ideally, yes, that is like you're the golden boy or the girl.
No, then if now what happens if all of us like do all this like filled up, then they'll see, okay, how is the color, whether it's dark, whether it's light, all these things, then they will start that one, color coding.
Possible, yeah, possible. Yeah. It's always relative grading.
Yeah.
Okay, fine. Yeah, so basically, please maintain something like this. Otherwise,
if everyone do this, then nobody will get bugs.
Yeah, we will be asked to shift to the Mumbai office maybe directly, like as inspiration to other people. See, every day they comment. Okay, fine. So, okay, we are back to milestones are done, labels are done. What else was there? I think this is a good time to take a break, right? Because the break was supposed to be at 12:30. Okay, nice. Is everyone tired already? Or is this stretch of continuous listening to bap 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 okay? Like it means basically for the next session onwards, do you want more frequent breaks and so on?
It's okay, man.
Okay.
It's nice, yeah.
Just let me know in the comments if you want break. I'm sorry, I'm not reading the comments because yeah, but just unmute and shout. Not very sure. So we finished only 1/3 of what we were supposed to. That sucks. Okay, but at least something is going on. Code review. Yeah. So this is the main part, which we most probably don't do, but we will have to do because there has been specific instructions from powers to be that code review must happen. Actually, code review we already saw. So I think Nitin, you were mentioning about that comment box under the diff, no? That git commit comment. So that is actually this beginning of code review. So we'll go into code review right now. So let's see, what can we code review? We'll just finish up this code right now. Can we comment? So I forgot all these things. Why are we still in 2? 2 is closed. Okay, it's a local branch. That's why it's still alive. So this is a good example. Mrinal, you had some question about this thing, no? That if there is a branch which is closed in the remote or in the
Yeah, so you mentioned something like branching out locally from your.
So 2 is still present in my local because I was working on it. But if you look at the, where is it? What is it called? Coding Camp. If you look at the branches here, 2 is gone. So now if I commit, let's do this. This is a good game. So let's say I say that, okay, we'll change it to 80. Very rudimentary change. Commit -am. Cooler. It pushed. Now where did it push to? That's the question. Let's see. It created a branch again. Okay. So basically, if your remote branch was dead, it will go and open another branch with the same name as your local branch. Okay. If a local branch exists, let's do that then. If the remote branch exists, yeah, that's it. Yeah, it will open up. Now the question is, how do you not do this, right? Like, means if this branch was already closed, why am I pushing it here again? So what you usually do is, one thing you can do is, if you have not yet decided that you are going to branch out, the changes you are making are not from a new issue. Okay, then you can just git branch, git checkout minus B. Minus B is for create a new branch and check it out. Okay, say that this is to fix date. Okay, your code will be here.
Hello.
Is something wrong with the network or?
Yeah, for a moment I thought my network went wrong. I think so. Maybe it's, something happened there.
So are they in office? Like Mandita?
Yeah, I think he's in office.
Okay.
He's in office?
Yeah, I think so because he was showing conference room mobile access.
Oh, okay. Lot of new people.
Yeah, a lot of new people we have not seen.
Yeah.
Okay.
What did he say, Ravi? He'll join back sooner.
Hello.
Yeah, he's back.
Yeah, for some reason I got kicked off the Wi-Fi. People were like, just stop. The other office people, surrounding office people. Jabber. Someone is keeping on talking. So sorry. Yeah. Is my screen shared? No. Okay, I'll share my screen. Yeah. So can you just remind me where I left you? Or where did I drop?
We were doing git branch. I think git branch of this is to fix that too.
Okay. So this checkout happened, right?
Yes,
Oh,
yes.
yeah.
Yes.
So basically, we realized that we are trying to write on modify a code in a branch which is already dead in the remote repo. So what we did was we took that local pseudo dead branch and branched out from it to create an on-the-fly new branch, and then we try to push it. Then when we try to push it, I can redo the steps again. Okay, let me redo because I got this remote access error. Then I got scared. What happened with the permissions and so on? Then I realized, okay, I don't have any Wi-Fi. So we were in Git branch. So we are currently in this is to fix that too. We are trying to we made this modification of 80 and we are trying to push it to this new branch. So if we just do git push, it will say this. This message basically means that there is no reference to this is to fix that too in the remote server here. Here we have branch 2, branch 1, and all those, but this seems to be a very new branch. So what GitLab is saying, or Git is saying, is that you can push still to a new branch. Just put a new link also on the online upstream origin or remote server case. So GitLab just tells you what to do. So you can just do whatever it says, just copy paste the same thing. It'll allow you to push. Okay. So once you push, you have, refresh. This is the difference between, this is to fix that too. And you can see it has 80. Okay. Now this is a temporary branch. You can also fix a TMP in front of it to say, or WIP, work in progress or something, to say that this is a temporary branch. This is not a issue at all or something. Just ignore it for now. And quickly, what you can do is our good old friend merge request. Then new merge request you can create from, this is to fix that too. And we wanted to put into what? Main, is it? Okay, we'll put it into main. And we'll continue. Merge.
Can we merge to main like directly?
Yeah, so the thing is, you can't push to main, but merge to main you can. See, if you can't push to main or merge to main, then how will you change main?
Yeah, I got it.
Right. So yeah, so basically the restriction that we usually like to put is don't push to main directly, because one day you're very frustrated, you change something, you were not careful, and then you say, it's Friday night, leave it, and you push to main, and then on the weekend the client's semiconductor manufacturing plant blew up. Okay, then it's a problem. So that's why always it's best not to push directly to main. Always go through a merge request. A merge request basically or usually entails a code review. Now we'll quickly cover what is code review. Code review is nothing. It's just a hopped up thing to give. We'll talk about it later. Code review in big companies like Microsoft, Intel, or places like this, which have like 10,000, 50,000 coders, is a a festive business kind of thing. Like for code review, you will set up a meeting that for let's actually mock a code review, how it happens in Microsoft. I'll need many of you to unmute your mics now, because we're going to do code review, how it happens in big companies. First of all, where am I? Oh, this is to fix it too. So what you can do is, I think you can remove local dead branches using git rm. Is it? I don't know. Some git command is there. I will do it later. So we'll get
master, I think, and you'll be updated.
Oh, is it? Okay, let's go to main.
No, there will be no data.
But they won't be removed, right, from local? There will be some local remove. This is there. Git remove local branch. What is it? -d. Git branch -d. So we'll remove this. We'll remove 2. Okay, now it's a sort of clean repo which reflects what we have online. Oh God, this was there. This is the problem with branches. See, this is why you need code review, because there will be, the coder is usually so busy coding, you won't keep track of all these things. Why did this? Okay. So you basically need a maintainer of the repository who will do all this cleanup. This has nothing, right? This so we can just delete it. That's useless, because we already branched out from that and merged into main. So main has 80 degrees as temperature. So this is fine, and this reflects what we have now. What is add replenishing? We'll remove add replenishing also. Okay, so code review. So we will quickly go into we are fine with one. We'll go into code. So this was supposed to be the Laplacian thing. So let's quickly finish off, not delay this problem too much. We will do updates. So time t equals 0 to 20. So one thing is Laplacian, capital L, but in code we always prefer to write small. In that sense, technically, this should also be small. We'll come to coding guidelines and style guides and all on Wednesday, because that is the day I usually prefer to have all the heated arguments and debates with on, because everyone prefers their own style, but the company has to follow one style. So we'll have a shouting match and then we'll settle on one style. Apply Laplacian, yeah. You can just copy paste these things. I'm pretty sure people who are used to Sublime and VS Code are screaming right now, like you could have done this entire thing in Vim with just 2 mouse clicks. But what to do? Here,
We are back to him because you restricted us from using VS Code in clusters. So.
Yeah, that is exactly why I stuck to Vim, because whenever you work on clusters, it's difficult. Yeah. So temperature, let's call it temp. I can't spell out temperature so many times. But don't confuse temp with TMP, which is temporary. This is a common problem that all heat conduction solver writers face. Oh, yeah. Now is I am pretty sure everyone knows FD, so I won't say why this is required, but it's a new array. We'll write double memory code. We're not going to do any optimization on fancy things right now. Okay. And there will be a CFL in front. So what is this? This is temp. But a CFL, I'm not in physics, so I don't know what that means. So something +1. I'm breaking one of the cardinal rules of coding nowadays, which is keep your lines restricted to 80 characters or less. I've already crossed 100. This is 4, is it? Or something, yeah. 2D, right? So, yeah, this is the finite difference version. So this is one thing, and then you have to basically copy the swap or copy. So go back again and do it everywhere. This seems to be a decent enough code. Oh crap. Okay. Okay, fine. Now this is a good place to announce that. So as you know, tell them to wait for 5 minutes. Okay. As you know, we are doing a lot of. Okay, let's finish this quickly. Then we'll come to a logical conclusion. Then I'll tell you something interesting. This looks fine, right? So suppose I am in a very, very big hurry and it's Friday evening, 5 o'clock. And I'm going to just do git add. Don't even know if the code will run fine or not. And add update steps. And I'll git push to my branch. Okay. Now, suppose I'm a developer. I don't have permission to. Okay, no one has permission to merge to master or push to master directly, main directly. So you will always have to go through a merge request. So given that the new commit that I've pushed here, as you can see, this one, I will be creating a merge request to main. Now there will be a panel of reviewers who will come and sit and discuss the pros and cons of the code that this person has written. So let's mock that once. This is called a code review. So new merge request I'll create and ask them to please merge and then run away myself and they will discuss. So I say, okay, this is the new merge request which has been created. Oh, I have to create it first and assign someone. So for example, who do I choose? Okay, this is only from my group. Oh, okay. Okay, fine. I'll put Ravi for now. Assigning to actually close the merge request, I'll put myself doing, and that's it. Okay, I'll create the merge request. Now, whether I get to merge it or not, the reviewer has to. Why does it say? Oh crap! The reviewer has to say whether it's mergeable or not, or what are the improvements I can make, and so on. Okay, so we will do that once. Why is it taking so long? Checking if merge request can be merged. Interesting. That is very weird. Code doesn't usually take. Did my net go again? No, this is fine. I think because, wait, I think I know. Wait, this is again permissions business. This permissions business is a hill. So someone who cannot merge cannot be a reviewer, is it? Oh, Ravi is recording. Then what I'll do is put someone. Okay, so I'll put this merge request on you, Hiroshi. So you can't run away for the next session. Okay. Okay, merge conflicts with it. That is fine. So now we will do a full role play of how to do this merge request. Now the thing is, before we go into this, should we keep this right away? Because this will require a bit of discussion. Should we do it after the break or should we do it right away? Because if you take a break now and then come back at 2, it's almost 12:20. In the meantime, there are hardware people who have just arrived with some new RAM which has to be put into the GitLab server itself. So the GitLab server will be going down right now if we take a break. So it's unfortunate timing. I did not expect them to come today, but this is the situation. So what should we do? Should we break now?
Okay.
Okay.
Yeah.
There's no show of hands feature in this basic G Suite, huh? It's there in enterprise.
Oh.
Yeah, you can't take a vote like that. Anyone who has opposition to taking a break now, it's like you've started something crappy, just finish and get it done with. Anyone? I won't mind, please speak up. Then we can finish it quickly. Okay, what is there in the other thing? We have spent 10 minutes left. 10 minutes will, I think, be okay. We can finish. Okay, let's finish this. Otherwise, unit tests is another, like you need a fresh mind to do that. Let's not do unit tests after code review. Huh?
Oh, you're doing.
Yeah, you want to say? Okay, fine. Let's take a break. I have to. Okay, fine. Let's take a break.
Just give it time.
Yeah. Okay. We'll get back at 2 o'clock. Is that fine?
Yeah.
Yeah. Okay. We'll break for 2 o'clock.
I need